Well, hey there, physics folks. Welcome to Doc Onco's Physics. My name is Keith Onco, and today what we're going to be doing is taking a look at how to solve a series circuit, how to analyze a series circuit. In the previous session, what we did was we took a look at current, an electric current in Ohm's law, and we're now going to take that and expand that a little bit into solving a series circuit. So what we have up on the upper right hand corner here, is what's known as a series circuit. So this guy right over here is a simple series circuit. And a simple series circuit is made up of a couple of things. One, it's made up of a voltage source. Okay, in this case we have a 20-volt battery or voltage source. And then it can be made up of one or any number of resistors or devices that provide resistance in the circuit. And we have three in this circuit. We have a 20 ohm resistor right up here, we have a 30 ohm resistor right here, and we have a 40 ohm resistor right here. In the lower part of the screen, what you see is a table. And this table is a graphic organizer that I use when I teach, and it just helps students to figure out what the voltages and the currents and the resistances are of the circuit. And the way the table works is that it uses Ohm's law, right? And it uses Ohm's law in going down the rows, so row 1, row 2, row 3, and row 4 for that matter, for the totals. All right, so the rows will obey Ohm's law, as you'll see in a minute, and the columns obey the series circuit rules, which we're also going to go over in a minute. So if we use the table, we can easily solve a series circuit. So let's see what a series circuit is. If you notice, we have a battery, and when the current leaves the battery, it's going to take a path like this. And the one thing that we notice is that the current leaves the battery, and it really only has one path to travel in. And that is a key to understanding or recognizing a series circuit. A series circuit is one where the current has only one path, or there's only one loop in the circuit. Okay? The same current has to travel through this resistor, the 20 ohm resistor, the 30 ohm resistor, and the 40 ohm resistor. Okay? And so the current is the same in all parts of the circuit. I total, if you will, once we figure out I total, that is equal to the current through I1, right, in I1, the current of I2, and the current of I3. I1 being the current through the 20 ohm resistor, say, I2 being the current through the 30 ohm resistor, and I3 being through the current through the 40 ohm resistor. Okay, so the current is always the same in a series circuit. Well, how can I use that in my table over here? Well, if I know the current for any one of the resistors, I know the current for all of the resistors in the total. So once I know one of the elements in the current column, I know the elements in all of the entire current column, if you will. Okay. Well, we also know that we have 20 volts up at the top of our battery. And voltage is known as potential difference as well. The only way you get electrons to travel in a circuit is if you have a potential difference, right? A voltage difference, if you will. And you can think of it as a pressure difference. And so if I have 20 volts up here, you can think of the bottom of this battery as being 0 volts. Okay? Well, if I have 20 volts up at the top of the battery and 0 volts at the bottom of the battery, what's happened to the voltage as I travel around my loop here? Where did the voltage go? Well, we say that the voltage is lost or the voltage is dropped across each and every resistor. So some is dropped across the 20 ohm resistor, some is dropped or lost across the 30 ohm resistor, and some is dropped or lost across the 40 ohm resistor. And by the time you get to the end of the last resistor, how much voltage do you have left? You have 0, or you have 0 pressure left. And from this point, the electrons just sort of drift back to the negative side of the battery. Okay. So voltage in a series circuit will split amongst the resistors. It does not always split evenly amongst the resistors. In fact, most of the time it won't. The only time it splits evenly among the resistors is if the resistors all have the same value. But if they have different values, which is the case in our example here, then they do not split evenly. Okay, and it's very easy to figure out just what that split is. Okay, so the voltage splits, the current is the same, and the total resistance of our circuit. How do we figure that out? Well, it's really easy. Our total of our circuit is just going to be R1 plus R2 plus R3 in this circuit. So it's the sum of all of the resistances. What else do we know? Well, we've just said that the voltage splits among the resistors. Okay, so I have a 20 volt supply here. Okay, I start out with 20 volts, and then that 20 is dropped across, or lost across each one of the resistors. So what can we say? Well, we can say this rule over here. The sum of all the voltage rises and drops in a loop or a circuit like this must equal 0, right? Well, I have a 20 volt rise in the battery here, right? And then I have voltage drops across each of the resistors, and those drops, when added up, right, have to equal the rise of the 20 volt battery. Okay. Well, let's look at analyzing our circuit. Using our graphic organizer, what I'm going to do is I'm going to fill in the information that we have. Right. So the values of R1 and R2 and R3 we know. Right. So R1 is, we're going to say that that's 20 ohms. I'm going to call this, I haven't labeled these up here, we'll call that R1. This will be R2, and the 40 ohm resistor will be R3. Okay. So R1 is 20 ohms, R2 is 30 ohms, R3 is 40 ohms. And so if I want the total resistance, right, the rule says that the total resistance of our circuit, our series circuit, is just the sum of everything, right? So we're going to sum up 20, 30, and 40. 20 and 30 is 50, and 40 is 90. So our total resistance for our circuit is 90 ohms. Okay, so we know that. What else do we know? Well, we know that the total voltage in our circuit is 20 volts. Okay, so I'm going to put that there. All right, so we have a 20 volt circuit. I'm sorry, 20 volts total in our circuit. Well, what did I say about our graphic organizer? Well, I said we can use the series circuit rules on the left-hand side of the screen here to fill in or complete columns. We can use Ohm's law to fill in or complete rows. If in any one of the rows in the table I have 2 of the 3 pieces of information, I can get the third piece. Well, the only row that has 2 pieces of information is the total row. I have the resistance of 90, I have the voltage, which is 20, and so I can get the current using Ohm's law, right? So V equals IR, or I total, is equal to V total divided by R total, which is going to be 20 volts divided by 90 ohms, all right? And so when we do that math, what we get is 0.22 repeating amps. Okay, so that's our current. But what did we say about current in a series circuit? Well, the second rule down here says that the current is the same in all parts of the circuit. So if I know the current for the total in the circuit, I know the current in all parts of the circuit. Right? So now I've filled in my column, my current column. Well, look at what I've got. In each row, I've got 2 of the 3 pieces of information that I need. Isn't that great? Well, voltage equals current times resistance. Right? So I can now find the voltage dropped across each one of my resistors. So let's try that. So if we multiply 0.222 times 20 ohms, right? 0.222 being our current, 20 ohms being R1, we get 4.44 for the voltage drop across R1. Same thing if I multiply 0.222 times 30 ohms, I get 6.66 voltage drop across the 30 ohm resistor. And if I multiply 0.222 times 40, I get 8.88 voltage drop across my 40 ohm resistor there. If I add all of those up, I should get something very close to 20 volts, which is my total voltage. Now, is it going to equal 20 volts exactly? No. The reason being that, we have truncated the 0.222. We've rounded it to just 0.222, right? And so I've got some rounding factor in here. So I'm not going to get exactly 20 volts, but I should get 19.9 something volts. It should come very close to our total voltage. Use the table. It's a great way of analyzing these series circuits. After you've done this enough, then you maybe not need the table. You can just start labeling things in the circuit, which is also a good way to do it. So let's try to do another circuit. Let's see, I'm going to draw a different one down here. Okay, so through the magic of being able to stop time, I've been able to create a new. Okay, so what we have here is we have a new circuit. We have a 10-volt battery right there. We have a resistor that's 6 ohms up at the top, that's R1. We have a resistor R2 where we don't know the resistance of it, but we know there's a 2-volt voltage drop across it. And we have a resistor R3 that's 2 ohms. So the first thing that we want to do is we want to fill in our table, because we've got a lot of different information here. And the table acts as a good graphic organizer to organize our information and allow us to use Ohm's law in the rows to solve for missing information, and the properties of a series circuit to solve for information in the columns. So let's fill in our information. Our total voltage is 10 volts. Okay. Our voltage for across R2 is 2 volts. Okay, we know that because it says it right there. All right, as far as current goes, it says the total current is 1 amp. So this is 1 amp, but we know that in a series circuit, the current is the same in all parts of the circuit. So I can fill in the ones there. We know R1 is 6 ohms. We don't know R2. We know R3 is 2 ohms. Okay. And that's all the information that we have. So let's see what we've got. Well, we've got a lot of information here we can fill in what's missing. So let's look at the total row here. We have 10 volts, we have 1 amp, all right? So we can get the resistance because Ohm's law is V equals IR, all right? Or R is V divided by I. Well, in this row here, in the bottom row, in the total row, V divided by I is 10 divided by 1, and so our total resistance is 10 ohms. Okay. If we look over on the column on the right, we have R1 is 6 ohms, R3 is 2 ohms, the total is 10 ohms, and remember the characteristics of a series circuit is that the resistance simply adds up. So the total is 10, that's got to equal 6 plus 2 plus R2, which means R2 must be 2 ohms. Okay. So does this work out for the row here for Ohm's law? Well, let's see. V equals IR. Well, I is 1, R is 2, and so that works out well. All right, let's look at row 1 here. The voltage, right, is going to equal 1 times 6. So we're going to fill in a 1 times 6 here. This is going to be a 6-volt drop here. I didn't mean to make that a 0. I just meant to put a circle in there. And R3 is going to be 1 amp times 2 volts. That's going to be 1 amp times 2 ohms, which is going to give us 2 volts in the voltage column. Do these add up? Well, 6 and 2 is 8, and 2 is 10, so everything works out. If you use the table, you'll find that solving these series circuits becomes very easy. Well, I hope that helps. The next lesson that we're going to have is going to be on parallel circuits, where we're going to do something very similar with the table, except that the characteristics of a parallel circuit are quite different than for a series circuit. See you then.